Okay, so here we have the complete component board that's just been finished, and I'll show you around. You have the DC converter here, you have a 12-volt cutoff switch, high voltage maintenance switch, you have the TBC prescaler here, which is for the state of charge meter, which is in the dash, your high voltage fuse, shunt, your main contactor, which closes and then sends full power to the controller. Here are your high voltage fuses. Here's the MCU control unit. This one basically allows you to program and control the chargers, the BMS's instruments in the dash. And there are a couple of relays switches in here, which is really handy. And here are basically all of the relays that I use to communicate and switch between the component panel here, the controller, which is connected to this 35 pin here, and as well as the motor. This right here is the motor encoder and the thermistor. And then you also, I'll run through all the connectors that are here. So this right here is the serial connector, which plugs into USB, a laptop, when you can control the and program the MCU, the Thunderstruck MCU. Here is your switched, or basically key switch, 12 volt to the component panel. Here is constant, which comes over from the battery, which is down on that side, will be down on that side when it's in the car, and your ground. And the ground is chassis ground that is also sent up to the front. So it shares the same ground as the component panel. And let's see what else you have here. This is the, right here, this connects to the Hall effect current sensor, which is going to be a high voltage cable coming out. It's a donut, which basically sits right around that cable and is able to do Coulomb counting, which tells you how many amp hours you have remaining on the pack, how many amp hours you've used, what your current flow is. Then you have here the DC output from the charger, which allows me to run a relay, which then allows me to choose between charge profile 1 or 2 with a switch on the dash. And what do we have? We also have a 12 pin, which connects to a harness which goes down through the motor deck and under the car. And that connects to the throttle, sends power to the cooling kit, and also allows you to operate a clutch switch. So when the clutch is depressed, you have a different set of regen, a different regen setting for when the clutch is in and the motor is free spinning. And here you have a chassis ground for the chargers. The cases of the chargers need to be grounded to chassis. Here you have CAN. These are the CAN signals that come from the MCU and connect to the chargers and allows you to program the chargers via CAN, control area network. Here is the DC output of both chargers. So the chargers are sitting here and here on the firewall. And that allows you, actually that goes to the high voltage fuse, which is this one right here, charger output. So that's where all these are going. And what else do we have? What else? Here's just the connector, which connects the input of the DC-DC converter, high voltage input, and it outputs low voltage. It outputs 12 volt to run everything in the car and to charge the 12 volt battery. So, and one more thing. This is the pilot proximity and ground, which will connect to the charging receptacle. And that allows the MCU to detect that the charger has been plugged into the receptacle, and then it's okay to go ahead and turn those chargers on. So, no, I could do a lot more, but that's just basically in a nutshell.